Hey there, let's learn about building graphs using independent and dependent variables. Here we have a dataset for data usage versus cost. As you already know, if you use more data, your cost will increase. In this example, data usage is called the independent variable and the cost is called the dependent variable. Because if you increase your data usage, your cost will also proportionally increase. Now let's try and make a graph using this data. Here we have the data usage on the x-axis and cost on the y-axis. The first point is 2 GB at 100. So we have 2 GB here and 100 rupees over here. So that's for first point. Next we have 4 GB and 200. That will be the next point. And we have 6 GB and 300. And then we have the third point, 8 GB and 400. There we have the fourth point. Let's draw a line through all these points. And as you can see, we get a perfectly straight line connecting all these points. And that's why this kind of relationship is also called a linear relationship. The word line is where the word linear comes from. Let's look at some questions to understand better. This question tells us a bank offers 8% simple interest on fixed deposits for students. Draw a graph to illustrate the relation between the sum deposited and the simple interest earned per year. So that means we need to make a table for sum deposited and the interest earned. And could you think which one would be the independent one and which is dependent? Clearly, the sum deposited should be the independent because that's what is in our control. Right? We give the sum to the bank and the bank gives us the interest. What we control is the independent variable. So it would be sum deposited in this case. Now what do we need to find? The annual interest obtainable for an investment of 300 rupees. And the investment one must make to get an annual simple interest of 56 rupees. Great. Let's start. So here we have the table that we need to build. So we have taken 100, 200, 300 because it's just easy, right? Because interest is always calculated as the base of 100 rupees because it's a percentage. So taking in multiples of 100 makes our job very easy. So let's start and find the interest for 100 rupees first. So interest, what is the formula? It is P into N into R by 100, where P is the principal, N is the number of years, and R is the rate of interest. So what is principal? Principal is the amount we deposit, which is 100 in our first case. And what is N, number of years? We need for 1 year because we need to find this interest only for the first year. And rate of interest as given is 8%. So R is 8 and divide that by 100. So 100 gets cancelled and we would end up with 8 rupees. Rupees 8 for our first interest earned. So first interest earned is rupees 8. Now let's try for sum deposited with 200 rupees. Now P becomes 200 and the rest of it remains the same because we are trying to see if I deposit what sum, how much interest would I earn for the same amount of time, in this case which is 1 year, and interest is obviously the same, right? So here we would get 16 rupees. So 100 2 times 2 into 8 is 16. So we get 16 rupees as the interest if I deposit 200. So that's 16 rupees. Now let's try for 300. P becomes 300. This is the same. So 100 times 3 and that would be rupees 24. C into 8 is 24. Finally, we have for rupees 400. So we get 400 times 1 times 8 by 100, which is 100 times 4. 8 4s is 32. So finally, we've completed our table. Now that we've built our entire table, let's plot the graph for this table because we need to find these answers from the graph. As you can see in the question, find from your graph. And we need to first find the interest for about 300 bucks, investment for an interest of 56. So this makes things slightly more tricky. Let's first figure out what is the axis. So here we have taken on the x-axis the sum deposited in multiples of 100 because we don't need to go granular than that for the purposes of this question. But on the interest side, we have taken in multiples of 4 to make things easier for us to figure out even if it is a smaller value. Right, now let's plot the points. The first point is for 100 we have 8. So for 100 you have 8, it's about here. Next, for 200 you have 16. So 200 16 is over here. Great. Next for 300 we have 24. So 300 and 24 is right here. Next finally for 400 we have 32. 432 right here. Great. Now let's connect these points and we have a perfect straight line. Now let's use this to answer our questions. The first question was, for a sum of 300, how much interest would I get? So for 300, we need to draw a line from the x-axis starting at that point and try to connect our line over here and see at what point the line connects with our existing point. So that's about over here. So from that point, we draw another line towards the y-axis to figure out the interest. So that would give us 24. So for a 300 rupees investment, you get an interest of 24 rupees. Perfect. The next question is, for an interest of 56 rupees, how much investment should one make? So if our investment is 56 rupees, so for a 56 rupee investment, which is on the y-axis, how much investment should I make? So first I need to start at the y-axis and draw the line touching our violet line, which will tell us how much sum should I invest, because that is on the x-axis. So from 56, let's draw a line which will touch our violet line. Great. So this, it's touching over here. So from here, let's draw a point down towards the x-axis. Perfect. We are at about 700 rupees. So that means for an interest of 56 rupees, you need to invest 700 rupees. Wait, we have both our answers. So for a rupee 300 investment, you get interest of 24 rupees. And for an interest of 56 rupees, you need about 700 rupees as the principal. Let's go to the next question. A train travels at a constant speed from station A to station B. The following table shows the distance covered at different times of the day. So we have the table over here, and I've taken the liberty of putting the time as the independent and distance in the dependent. At 10 a.m., the distance covered is 60 kilometers. At 11 a.m., it was 120. At 12 p.m., it was 180. And 1 p.m., it was 240. Perfect. Now, what do we need to find? First, how much distance did the train cover during the period 11:30 to 12:15? Next, at what time had the train covered a distance of 150 kilometers since departing from the station A? And what is the speed of the train? Let's start by plotting the graph. Time is the x-axis, distance in the y-axis. So we've chosen time on the x-axis, and as you can see, it's 10 a.m. to 1 p.m. and we've taken intervals of 15 minutes because it is important to go as granular as possible depending on the question. We have station A starting and we ended at station B. And we've also taken distance on the y-axis in intervals of 20 to again make it easier for us to answer the questions that we have. First, let's plot our points. So first one was at 10 a.m. we are at 60 kilometers. At 10 a.m. we are at 60. Great, that's our first point. At 11 we are at 120. So at 11 we are at 120. So here, and at 12 we are at 180. We are at 180 over here, and at 1 we are at 240. So at 1 p.m. we are at 240 right over here. And let's join all these points. Perfect. We have the linear relationship, which makes things easy for us. Now let's answer questions. So first question is, how much distance did the train cover during 11:30 a.m. to 12:15 p.m.? So from 11:30, let's drop a line from at 11:30 to see what distance it has covered till then. So at 11:30, we can see the point is over here, and we need to drop another line to this side. And this is 12:15, and we need to drop another line to that side. Let's see what we get when we drop lines. So at 11:30, we can see that at this point, the train is covering exactly in between 140 to 160, which is about 150. Here we are at 150 kilometers. As you can see from the graph, which is over here, this is the point. So when you plot at 11:30 and see where our line is touching the y-axis, we're at 150 kilometers. Now let's do the same at 12:50. So 12:50, we plot a line. 12:15, the point that's touching over here, and where you see it touches the y-axis is about 1/4 of from here. Can you see this is 1, this is 2, this is 3, this is 4. That's about 1/4. So that means from 180 to 200, we have 1/4. So it's 20 kilometers, right? 200 minus 180 is 20. What is 1/4 of 20, which is 5 kilometers? So that means 180, 185, 190, and 195. So this point is 195 kilometers. 195 kilometers. So this means the distance in between these two would be 195 minus 150. That is 45 kilometers. Perfect. So that's the first question. At what time had the train covered a distance of 150 kilometers? This one's easy, isn't it? We already know, right? So at 150 kilometers, we were at 1130. So 150 is right over here. So this was a 150 point. So at 150, we were at 1130. And what is the speed of the train? That is an interesting question, isn't it? So what do you think? What do we need to find the speed of a train? We need distance and we need time. And we have both over here. So if you see, for every 1 hour, so from 10 to 11, from 10 a.m. to 11 a.m., what's the distance that's being covered? So at 10 a.m., we were at 60 kilometers. And at 11 a.m., we are at 120 kilometers. So that means in 1 hour, the train is traveling 60 kilometers, correct? 120 minus 60, which is 60 kilometers. So in 1 hour, the train is traveling 60 kilometers. So speed equals distance by time. So 60 kilometers divided by 1 hour, which is 60 kilometers per hour. That is the speed of our train. And that's that. We finished our questions. Here's a bonus question. Create your own scenario with independent and dependent variables like height and age, or hours you study, or test scores, whatever makes you feel interested, and sketch what the graph might look like and explain why. I'll see you next time.